Welcome back to the Nerdwork Nexus. We're kicking off the new year with a look at the potential of space-based solar power.
So we're talking about harnessing the sun's energy directly from space, thanks to projects like Caltech's Space Solar Power Project,
the
SSPP, and the European Space Agency's Solaris program.
Right.
It's getting closer to reality every day.
And that's why we wanted to dedicate an entire episode to this.
For sure.
Whether you're a scientist looking for your next big career move, this is a field you need to be paying attention to.
Absolutely, because to understand the job opportunities, we first need to understand the technology itself. So think about it.
Okay.
The amount of sunlight reaching Earth's surface varies wildly due to weather, time of day.
Makes sense.
And even the atmosphere itself absorbing some of the energy.
Right.
And you can't generate solar power at night.
So even on a clear day, we're not getting the full potential
Exactly.
of solar energy.
Not even close. But in space, solar panels would be bathed in constant unfiltered sunlight.
All right.
10 times more intense than what we get down here.
10 times.
10 times.
That's wild.
That means a space-based solar power system could theoretically generate significantly more energy than a comparable ground-based system.
Yeah, 10 times more intense. That's a huge difference, especially with global energy demands expected to skyrocket by 2050.
I got it, and that's why institutions like Caltech and the ESA are investing so heavily in this research.
Speaking of Caltech, they recently achieved a major breakthrough, right?
Oh, yeah, big time.
Didn't they successfully beam power wirelessly to Earth?
They did.
That's amazing.
It was a huge milestone for the SSPP.
Okay.
Their prototype called MAPEWL, which stands for Microwave Array for Power Transfer Low Orbit Experiment.
Okay.
Successfully beamed detectable power to receivers at Caltech's Moore Laboratory.
Okay, but how does that even work? We're talking about some kind of giant laser beam?
No, not quite.
Shooting energy through space?
No, it involves a clever use of microwaves. Okay.
And a technique called constructive and destructive interference.
Interference.
Yeah. So imagine you drop 2 pebbles into a pond.
Okay.
The ripples they create can either add together to make bigger waves. That's constructive interference. Or they can cancel each other out.
Right.
That's destructive interference.
I'm with you so far, but how does that apply to beaming energy?
So MAPLE uses an array of microwave transmitters.
Okay.
By precisely controlling the timing of each transmitter.
Okay.
They can create specific interference patterns in the microwave beam.
Okay.
This allows them to focus the energy in a specific direction without any moving parts.
So by manipulating these interference patterns, they can essentially steer the energy beam.
Exactly.
Wow.
And that means they can aim it precisely at a receiver on Earth.
Okay.
Even as the satellite is orbiting the planet.
That's incredible.
It's a remarkable feat of engineering. So Caltech has proven that wireless power transmission from space is actually feasible.
Right. And while this was just a small-scale demonstration, it's a major step towards making space-based solar power a reality.
So what about the ESA?
The ESA has their Solaris program, which is focused on assessing the feasibility of space-based solar power for Europe.
Okay.
Their vision involves a massive satellite in geostationary orbit.
Geostationary.
Meaning it would stay above the same point on Earth.
Right. Okay, that makes sense for continuous power delivery.
Right.
But just how massive are we talking?
Their reference design envisions a satellite capable of generating 2 gigawatts of power.
2 gigawatts. To put that into perspective for our listeners, what does that translate to in terms of energy production?
That's equivalent to the output of a nuclear power plant.
Wow.
Enough to power a city of over 1 million homes.
They're really thinking big.
Yeah.
But I can only imagine the logistical challenges involved in building something that massive in space.
You're absolutely right. And that's one of the key questions the ESA is trying to answer with their Solaris program.
Okay.
Is this even technologically and economically feasible?
Right, because it's one thing to demonstrate wireless power transmission on a small scale.
Right.
But scaling that up to a gigawatt level is a whole different ballgame.
For sure.
Not to mention the cost of launching something that massive into space.
Exactly. And that's where things get really interesting.
Okay.
Remember, space technology is evolving rapidly. Companies like SpaceX have drastically reduced launch costs with their reusable rockets.
So that's right.
Plus, the cost of producing solar panels has plummeted in recent years. So the economic equation of space-based solar power is constantly changing.
Yeah.
That could make space-based solar power even more viable.
But what really fascinates me is the ripple effect this could have on the job market.
Oh, absolutely.
We're talking about a whole new industry emerging, right?
Exactly. And that's where things get really interesting for anyone with a passion for science and technology.
What kind of jobs are we talking about?
Well, first and foremost, we're talking about aerospace engineers.
Right, of course.
Designing and building these massive structures to withstand the harsh environment of space is no small feat.
Getting those solar panels into orbit is crucial.
Yeah.
What other expertise is needed?
Robotics experts will be essential for assembly and maintenance.
Space robots, that sounds straight out of a sci-fi movie.
It is pretty sci-fi.
But incredibly cool.
Very cool.
Yes.
And then you have material science, which is absolutely critical.
How so?
We need lightweight, ultra-durable materials that can withstand extreme temperatures, radiation, and micrometeoroid impact.
Right, it's got to hold up out there.
It does.
Yeah.
Developing these advanced materials will require groundbreaking research and innovation.
It's fascinating how the success of such a large-scale project hinges on advancements in so many different fields.
Yeah.
It's not just about aerospace engineering. It's about pushing the boundaries of materials, science, robotics, and energy conversion, too.
Precisely. And let's not forget about the expertise needed in energy conversion and wireless power transmission.
Of course.
We need brilliant minds to develop highly efficient systems that can convert sunlight into electricity and then beam that energy over vast distances with minimal loss.
I imagine specialized skills in those key areas. We talked about aerospace engineering, robotics, material science.
Yeah.
Those are going to be in high demand.
Absolutely. And don't underestimate the value of internships and research opportunities.
Right. Get that experience.
Getting hands-on experience in a related field can give you a significant advantage.
Okay, so job seekers, take note. Start building those skills and connections now.
Start now.
And for our listeners who are on the hiring side, what should they be doing to attract top talent in this emerging field?
Hiring managers need to be proactive.
Okay.
Reach out to universities and research institutions. And really showcase the exciting work being done in space-based solar power.
So it sounds like companies that are early adopters in this field are going to have a real advantage in attracting the best and brightest minds.
That's right. This is a chance to be at the forefront of a technological revolution, and that's a powerful draw for ambitious scientists and engineers.
So let's shift gears a bit and talk about the bigger picture.
Right.
If space-based solar power does become a reality, what could that world look like?
Well, imagine this. Vast arrays of solar panels orbiting Earth, silently collecting the sun's energy and beaming it down to cities all over the world.
It's almost poetic.
It is.
A silent symphony of energy flowing from space to Earth.
And it's not just about aesthetics.
Right.
Imagine remote communities currently lacking access to reliable electricity being powered by these space-based systems.
Right. That's really important.
It could truly transform lives and economies.
It's about social impact and global equity.
Absolutely. And we can't forget about the environmental implications.
Of course.
A significant shift towards space-based solar power could drastically reduce our reliance on fossil fuels, paving the way for a cleaner, more sustainable future.
It's a compelling vision, but as with any new technology, there are bound to be concerns and challenges. What are some of the things we need to be thinking about as this technology develops?
One major concern is the potential impact on astronomers.
Astronomers.
Yeah, these massive structures in space could reflect sunlight and interfere with astronomical observations.
That's a valid concern. We don't want to solve one problem by creating another.
Right.
How are engineers addressing this issue?
They're designing the satellites to be as non-reflective as possible, using materials and coatings that absorb rather than reflect sunlight.
Right.
It's all about finding ways to minimize the impact on astronomical research.
So minimizing the visual footprint of these solar power satellites is a top priority.
Absolutely. And there's also the issue of space debris.
Oh, yeah, that's right.
Launching and deploying these systems will inevitably add to the amount of material we have in orbit.
Right. It seems like space traffic management is going to become increasingly crucial.
It is.
As we venture further into space.
It absolutely is, and international cooperation will be key to ensuring that we develop and deploy these technologies responsibly.
What other potential concerns should we be aware of?
Well, some people have raised concerns about weaponizing this technology.
I can see why that might be a worry. After all, we're talking about beaming concentrated energy from space.
Yeah, it's an important discussion to have.
All right.
However, it's crucial to understand that the technology for space-based solar power is fundamentally different from weaponized directed energy systems.
Okay.
The power density used for solar power transmission is far too low to cause any harm, and the focus is on spreading that energy over a wide area, not concentrating it into a destructive beam.
So no Death Star scenarios.
Exactly. But it is important to have these conversations and ensure that the development of this technology is guided by ethical considerations.
Absolutely.
And a focus on peaceful applications. And finally, there's the issue of cost.
Right.
Developing and deploying is a massive undertaking, requiring significant financial investment. But as with any new technology, costs are expected to come down as the technology matures and we achieve economies of scale.
Right.
Think about how much the cost of solar panels has decreased in recent years.
Okay, so it's an investment in the future. Now it's time to get under the hood and answer the big question.
Yeah.
Beaming energy through the air, like how efficient can that actually be?
It's surprisingly efficient.
Really?
Microwaves can pass through the Earth's atmosphere with very little energy loss.
Okay.
Even through rain and clouds.
So we're good on a cloudy day.
You're good to go.
That means we can have a reliable stream of energy regardless of the weather on the ground. So we have these solar panels in space collecting sunlight, converting it into microwaves and beaming them down towards Earth. What happens on the receiving end?
Okay.
How do we capture that energy and turn it back into usable electricity?
That's where rectennas come in, short for rectifying antennas.
Okay.
Essentially, these are giant antenna arrays designed specifically to capture those microwave beams and convert them back into DC electricity.
So it's like a giant wireless charging pad for the entire planet.
That's a great analogy.
That's pretty cool.
And one of the most exciting aspects of this technology is that the energy can be beamed to specific locations with incredible precision.
Okay.
Imagine being able to power a remote village in the middle of nowhere without needing to build expensive and disruptive power lines.
It sounds incredibly promising. But I know there are still a lot of engineering challenges to overcome.
Oh, for sure.
For example, what about the sheer size of these structures?
Yeah.
How do we even build and launch something that massive into space?
That's one of the biggest hurdles facing space-based solar power.
I imagine.
There are a couple of main approaches being explored.
Okay.
One is to build a single enormous satellite in geostationary orbit.
Right.
Similar to the ESA's reference design we talked about earlier.
The one that could potentially power an entire city.
Exactly. The advantage of that approach is continuous power delivery.
Okay.
But the downside is that you're talking about a structure that could be kilometers across.
Yeah.
Which is incredibly complex and expensive to build and launch.
So what's the alternative?
The other approach is to use constellations of smaller satellites in lower orbits.
Okay.
Each satellite would be more manageable in size.
Yeah.
And they could work together beaming energy between each other to create a continuous flow of power.
So more satellites, but smaller and potentially easier to launch.
Right.
What are the trade-offs there?
Well, coordinating a network of dozens or even hundreds of satellites adds a lot of complexity to the system. Maintain their orbits and adjust their positions to ensure continuous coverage as the Earth rotates.
Yeah, that's a lot of moving parts.
And that's why it's such an exciting field to be in right now.
Yeah.
There are so many unanswered questions and so much room for creative problem solving.
It's fascinating to think about the ripple effects this technology could have, not just on the energy sector, but on fields like robotics, materials science, and even international relations.
I completely agree.
Oh.
And as we wrap up this look into space-based solar power, I think the key takeaway for our listeners is this.
Okay.
The future of energy is not set in stone.
Right.
It's something we can actively shape through research, innovation, and collaboration.
That's an inspiring message to end on. Thanks for joining us on the Nerdwork Nexus today.
My pleasure.
And to our listeners, keep those neurons firing, and we'll catch you next time.